Hi, y'all. I'm going to give you a little bit of an introduction to vectors and scalars here. I know that I already talked about vectors in a prior video, so some of this is going to be a little bit of repetition. That's all right. The other video was targeted specifically at helping you out with the lab. So this one will be more of a general introduction. So first off, when I say vectors and scalars, we need to define our terms. What do those mean? A scalar is some physical quantity that has no direction associated with it. So if I ask for examples of scalars, y'all might be able to tell me, might come up with something like, well, body temperature. So temperature would be a good example because it's definitely a physical quantity that doesn't have a direction associated with it. Other things are, well, distance. If I talk about the distance I travel, I don't necessarily have to talk about direction as well. So I could talk about distance traveled. I could talk about the speed that I'm moving at. If I tell you that I'm going 65 miles per hour, well, there's my speed. Okay, so those are examples of scalars, and there's plenty of others. Time would be another one as well. Vectors, on the other hand, have both size and direction. And you see that word magnitude there on the screen. And magnitude is honestly just a fancy word for size. So when we ask for the magnitude of a vector, we're asking for the size of a vector. Examples of vectors are things like displacement, which is basically the distance from your starting point to your ending point, as well as the direction between your starting point and ending point in a straight line. Okay, so when it says how far and what direction you traveled, that basically means if as the crow flies, from start to finish, how far would that crow have flown? How what's the distance between start and finish, and also what's the direction? And when I say direction, that's got an angle associated with it. I can't just say northwest unless I literally mean 45 degrees north of west. I've got to supply some kind of angle information as well. Velocity would be not just the speed you travel at, but also the direction you're traveling in. So in our day-to-day language, we might use speed and velocity interchangeably, but they mean very different things in physics. If I'm talking about velocity, I'm talking about the speed and the direction of travel. All right. So we'll spend at least the first part of this class, Physics 111, I mean, talking about velocity and acceleration for the first couple of weeks. All right. If I want to denote a vector, well, how do I do that? Well, I make sure that I put this little arrow over the top of my variable that I'm using to describe my vector. So if I'm talking about vector A, then my notation needs to be an A with a arrow over the top of it. All right. So just like this, and we can think of a vector as an arrow. In general, the bigger the size of maybe my displacement or my speed, the longer I should make that arrow. So if I'm comparing, say, maybe 10 meters per second to 20 meters per second, then that 20 meters per second should be twice as long as the 10 meters per second. So we can think of a vector as an arrow. It's got both magnitude and direction. Let me get rid of my print on the screen there. There we go. So it's described by both, again, how, magnitude, how long the vector is, and the direction it's pointed in. All right. Something a little interesting about vectors is we can move these guys basically wherever we want, as long as we continue to point it in the exact same direction and don't change its length. This is useful when we want to do some stuff like add vectors together. So we can displace this guy wherever we want, just as long as we don't change its direction or its size. And we'll do some of that in a future video. All right, I already said that displacement is a vector, so here's an example. We've got a car that starts out at some location and then drives 2 kilometers, and it looks like the ending position is what, 2 kilometers and an angle of 30 degrees north of east from the starting position. Okay. So literally displacement is the distance and direction from the starting point to the ending point in a straight line. All right, so let's do a little example of that. So let's say that we've got somebody named Mary. Mary starts from her house. She drives 1 mile north, then 1 mile west, then 1 mile north, then 2 miles west to get to work. What we want to do is we want to draw a sketch of this, and we want to include in that sketch a vector showing her displacement. We want to answer the questions, what's the total distance Mary's driven, and also what's the magnitude and direction of her total displacement. So that's going to be our task here. All right, so to start this off, I'm going to go maybe 1 mile at north, and then maybe 1 mile west, and then maybe 1 mile north, and then maybe 2 miles, something like that, west. All right, and then so that's basically, you know, kind of a roadmap, bird's eye view of what Mary's done. So that's the trip she's taken. But if I actually want to draw a vector showing her displacement, I need to go from start to finish there. Oops, go away. I need to go from start to finish. And you know, if I would like to be able to draw straight lines, but I'm struggling a little bit. So bear with me, please. All right, so that right there satisfies our first goal that I had on the previous page, is that I wanted to, you know, show how Mary drove, and I also wanted to show Mary's displacement vector. And we can call this maybe vector M. That is awful. Why did that disappear? I don't know, but let's try and fix this real quick. You know, the nice thing about these videos is that you can speed them up and watch them back at double speed. All right, so there's that, and we're going to call that vector M. Okay, and it points from the start to the finish right there, and you notice that all the arrowheads point from the start to the finish. All right, so we're asked, what is the distance that Mary has traveled? Well, I think the distance here is pretty clear. She goes 1 mile, and then another mile, and then another mile, and then 2 miles. So the total distance she's driven is 5 miles. Now, on the other hand, we're asked for her displacement. And in order to figure that out, we need to maybe redraw this a little bit. So I'm going to redraw this down here. There's that vector. That's Mary. Okay. And let's see, we can draw in a couple of pieces. We'll draw in a piece in the X direction and a piece in the Y direction. Okay, why am I doing that? I'm doing that so that I can figure out the length of M. If we look here, Mary goes 2 miles plus 1 mile. Mary goes 3 miles overall to the west. And she goes 2 miles north. So what I want to figure out now is what exactly is the size of that hypotenuse M. Here we're talking about the magnitude of the vector M. The way we represent the magnitude, the size, is just with an M without the arrow sign over the top of it. Well, y'all can see that I've got a right triangle here. Okay, I've got a 90-degree angle between the piece to the west and the piece to the north. So I can use the Pythagorean theorem to figure out the hypotenuse, the magnitude of M. So M squared is equal to 2 miles squared plus 3 miles squared. When I do this, I get M squared is equal to, let's see, 2 squared is 4, 3 squared is 9, and those are square miles. That looks like 13 miles squared. And then, so Mary is going to have driven or excuse me, it's going to have a displacement, an overall displacement that looks like the root of 13 miles, and that ends up being what, 3.6 miles. Okay. When I took the square root of both sides there, it's not just the number 13 that gets the root; it's also the units that gets the root. That makes sense, because if I'm talking about a displacement, it should be miles, not miles squared. So the size of Mary's displacement is 3.6 miles. All right, so that answers the size of her displacement, but it does not answer, it does not get us to our full result that we want, which we're asked for. What is the, we're asked what as well, what is the direction of Mary's displacement? So let me see if I can just erase, maybe not. Okay, there we go. All right, so what we need to do is we now need to figure out what is that angle, theta. Well, if I look at that angle theta and I look at the sides that I have, I've got the adjacent side to theta and I've got the opposite side from theta. So this looks like, let me switch ink colors, opposite, oops, opposite right there, and adjacent right there, adjacent. Okay. So thinking about my SOHCAHTOA, it seems like tangent would be actually the trigonometric function that I want to use. SOHCAHTOA, tangent of theta is opposite or adjacent. Well, let's see. If I plug in here, that'd be 2 miles over 3 miles. I don't know why my stylus is struggling. It's 2/3. So I've got tangent of theta is equal to 2/3. Well, let's see. I need to get rid of that. I need to, supply the angle for theta. What would that actually be? Well, I need to take the inverse tangent of both sides in order to cancel out that tangent. So theta is going to be the inverse tangent of 2/3, and that angle ends up being 33.7 degrees. I'm not quite done yet though, because I have to say 33.7 degrees from what? This is 33.7 degrees north of west. All right. So the boxed information there is my answer for Mary's displacement. She is 3.6 miles from her starting point at an angle of 33.7 degrees north of west. And so that's my overall answer there for that question. All right. So lastly, we're asked, what are the x and y components of Mary's displacement vector? Well, we figured that out already. We said that Mary's was 3 miles west of her starting point. Y'all, I'm sorry for this, for the stylus. I got to fix this. 3 miles west of her starting point. Let's see, if she's 3 miles west, we typically think of east as the positive direction. I mean, it's to the right, and west is a negative. So we need to make sure that we throw in a negative sign right here. So it's a negative 3 miles. And Mary's y component is what? She went 2 miles north. So that'd just be a positive 2 miles. Okay, so there's Mary's x and y component. The x component's negative because she went west. Y is positive because she went north. All right, that does it for this. I will do another one here, maybe in a few minutes.